It's no secret that things don't always work out in a lab, but that's part of the point, right? And it's generally all good as long as you're learning from your mistakes. In the last video, we said we were going to terminate bare fiber spools with splice-on connectors, but we decided to only publish the preparation phase of that video. Here's why. We were able to get both spools terminated, but it wasn't easy and many mistakes definitely were made. The biggest one was that we failed to record most of the final termination, as our overhead camera here shuts off after 30 minutes of recording, every time. There's a long technical reason for that, and you can check the community tab in the channel for an explanation if you're curious. And I totally missed that the camera shut off, as I was so focused fixing issues while terminating the spools, I completely forgot to check that one minor detail. Plus, we don't yet have our own fusion splicer for the lab, but we're fortunate enough to at least borrow one from a friend for a few days, so we can't just recreate what we did as easily as we would have if we owned a splicer now. We assume most of you don't have your own fusion splicers either, so we will try not to rely on needing one for a while for our content as well. For the past few weeks, we tried to piece together the termination video, but it just couldn't turn out the way we wanted it to. That means we're going to have to redo it with the next batch of spools we get. So instead of covering that, this video is going to talk about some of the challenges of terminating the spools properly, how we overcame them, and what we recommend after our experiments. That includes using the Optic's SOCs, which we had mixed results with, leading to our ultimate conclusion of sticking with pigtails moving forward. If you are interested in terminating fiber spools for your own lab, we think we found some helpful information, so stick around and we'll share what we've learned. Let's get started. So here we have our SC-APC terminated spools with a pigtail on the outside and an Optic's 3X SOC on the inside of each spool. We'll explain why we have one of each in a few minutes, but let's talk about the SOCs first. We mentioned in the last Fiber Lab video that we saw advantages to using SOC over regular pigtails and decided to try them out for our spools. However, after the initial experiments and multiple test installations, we observed some application-specific challenges and general shortcomings with the Optic's 3X SOCs for our use case. The first issue for us was cost. From what we priced out, the Optic's 3X SOCs run about $75 to $90 per 10-pack, which comes out to nearly $8 to $10 per termination. Now, it's a quality product, and in the right application, SOCs make sense, but an important goal of ours was to find economical ways to make fiber labbing more accessible, so that's a potential barrier. The main proposition of the 3X SOCs is that you get up to 3 opportunities to terminate the fiber stubs, which helps to recover from bad cleaves or splices, but there are other reasons you might need to re-terminate. The kits only come with 10 30mm protection sleeves. And in trying to align the furcation tubing that we added with the fiber stub, we used up 5 sleeves just because of our mistakes, such as forgetting to first insert the fiber through the silicone boot before the sleeve. Realizing that, we tried to get a 40mm sleeve to work instead, with mixed results. We don't recommend that. So the issue here is that while theoretically most failures occur before you heat the sleeve, chances are high you're going to make mistakes requiring to cut off some sleeves. But in doing that, you're going to run short on the 30mm sleeves, and since most splices use 40 or 60mm sleeves, you'll be out of luck on alternatives. Now granted, the more you work with these SOCs, the better you're going to get, such as putting on the silicone boot first. It would be great if Optics provided 15 to 20 of the sleeves instead. We were also curious why the kits only came with 10 instead of 12 SOCs, since most termination work is done in multiples or divisions of 12. We can see some inventory issues there with techs in a grab-and-go mode that end up running short, especially if they run low on the 30mm protection sleeves in the field. So while we like the added protection that the SOC provides to the splice, we decided that the trade-offs compared to a pigtail weren't enough to justify the added costs, especially for lab use. Again, we value the advantage of these SOCs for the right application, but moving forward we'll use pigtails when needed for our lab. So with that said, We decided to try both options for each spool, which is why you see an SOC and a pigtail. Now, the original concern that made us consider SOCs was because the pre-terminated spools we bought had either pigtails or half of a patch cord spliced to the bare fiber itself, which is a real failure point risk. But adding the furcation tubing like we did mitigates the risk, so we then tried to solve for just that issue alone. So for the pigtail termination, the fix was a relatively easy three-step process once we worked the kinks out. First, you splice the pigtail to the bare fiber using 900 micron and 250 micron fiber holders respectively. You can't grip the furcation tubing that we've added because there's no adhesive to keep it into place. So you have to clamp the bare fiber for the splice. Second, carefully slide the entire length of the furcation tube close to the fiber joint and position the protection sleeve over both sides. Then lastly, you heat shrink the sleeve, holding both sides of the tubes together. This produces a better protected splice and reduces the amount of exposed fiber near each side of the termination. Secure the fiber pigtail with tape, clean the connector, and attach an SC-APC adapter with a dust cover on the opposite side. With that, your spool will be ready for acceptance testing. I know we went through that pretty quickly, and it's still a lot of steps, especially for someone relatively new to fiber optics. We will make a video demonstrating this in the near future, as soon as we get our Fusion Splicer, but in the meantime, I recommend acquiring pre-terminated spools if you can. We readily admit that prepping, terminating, testing spools can be a tedious, error-prone, and even frustrating process. But if you do it several times, you will start to get the hang of it. So now that we have our spools terminated, it's time for acceptance testing so we can finally get them installed in the rack and move on to some more interesting stuff with the lab. We'll be covering the testing steps in the next video. We're only 3 videos in, but if you like what you're learning, please be sure to subscribe and share this with your fiber nerd friends. We've got a lot of exciting projects planned, and I promise to make sure that we record it all. Thank you.